My God, I have to repeat. Um, we have set of x and y's. X here is a voltage measured in millivolts. Y we have a temperature using a thermocouple, for example, which is measured in degrees Celsius. We take a temperature bar, put a thermometer which is taken as a reference point, put a thermocouple connected to a voltmeter. Heat the bar when 40 degree Celsius comes in the thermometer. You take what is the voltage reading from thermocouple. Put 40 here, 6.2 here. Similarly, for 50, 60, 70, you keep taking the reading. No necessity that it should be a rounded figure, it can be 41, 42, something like that. So you take this figure, make this table by yourself for a practical purpose. In examination, it will be given. Once it is given, I assume you know how to build y is equal to mx with c. That's a straight line equation. This equation tells if I know what is x is the voltage that is received from the thermocouple, I will be able to tell what is the actual temperature, provided m and c are computed from this particular x. So now, for example, instead of using a conventional mathematical notation, I am using our notation in our field. Instead of y, I call it as y p out, the output voltage is equal to 4 times. Instead of x, I am using another variable b in minus 4. So m happens to be minus 4, c happens to be minus 8, and y is equal to mx. Is it alright? Okay. So this equation, this is an example equation. This need not be any particular thermocouple or anything. Just for illustration of the process. So this is m, and this is c, and this is of course x, this is y. So that will exactly match with c. Now, having drafted this, now I have to realize this circuit in the electronics. I have to realize this equation in circuits. How do I do that? I know yesterday, the last class, we have learned summing amplifier. What is summing amplifier? You have two inputs that is given to an inverting end, right? There is a feedback. This is, they call it as R2 or feedback resistance. Yeah, it's R2. No, RF. This is R1. This is R2. And this is feedback resistance. This is what is this? This is R1 to R4 input resistance. Here it is input 1, V1, input 2, and the equation for this, the output voltage here, I call this as V out. This V out is given by minus feedback resistance divided by input resistance times that input plus feedback resistance divided by the corresponding input resistance into that voltage times V feedback resistance divided by input resistance times the voltage, that particular voltage for that first input. For second input, contribution of second input for the output is feedback resistance divided by input resistance times the input voltage. So we have RF divided by R1 times V1, RF divided by R2 times V2. Okay, so that is the output equation that we have. Now, all we need to do is this and this. Now I have to match. From this general equation, I have to reduce to this equation. Simply, I need to do that. If I know how to do that, that means I know how to design a calibration circuit. So how do I achieve this? Maybe I'll write here for your. Is it visible? Now V1, I'm going to call it as V in. just changing the name. Otherwise, no, there's nothing. So it is begin. What is so easy for me to okay. Anyway, first we do this, then probably go there. This ratio, anyway, minus sign is there. So even if I multiply the minus sign inside, remove the brackets, this will become minus of this and minus of this. Alright? Yes? And this ratio, I have to make it 4. This ratio I have to make it 4. So how do I do that? Maybe RF I put 4 kilo ohms, R1 I put 1 kilo ohm, then this ratio will become 4. So minus 4 times Vin. This you will get. Alright? Right? Now the remaining quantity